Good morning, good afternoon, and possibly good evening, depending on where you are. My name is Gerald Verbeek, and I want to welcome you to the second webinar on foundation decarbonization and reuse. Before we get started with the program itself, just a quick reminder that the attendees are all muted, but it doesn't mean that you cannot interact with us. Please use the Q&A chat box to give your questions, because after the presentations, I will be moderating a Q&A for the remainder of the hour, so that you have every opportunity to ask your questions and hopefully get the answers that you're looking for, rather than only hear the presentations from two people that I've invited for this webinar. So please don't hesitate to use that Q&A box. People that I've invited, Andy Boeckmann from Dan Brown and Associate, and Tony Sangiuliano from the Ontario or the Ministry of Transportation in Ontario. I picked them on purpose. For those of you that were there during the first webinar, we had somebody from an engineering firm there. We had somebody here from a contracting firm. And if you haven't seen that webinar, you can go to the foundationreuse.com website and you can watch it again. But we talked there about different stakeholders. And I think it would be good to get somebody now from an owner side. Tony, of course, with the Ministry of Transportation in Ontario, looks at this whole thing. And Andy has done some work where he helped an owner as well assess the potential for reuse of foundations. And that's what his presentation will be all about. So you hear a different stakeholder perspective today. Moreover, the two presenters we had last month, or 2 months ago, were from Europe. This time we have them both from North America to show that foundation reuse is really happening all around the world and should be focused on all around the world. But let's just give, for those of you that are not that familiar, that were not part of the first webinar, a short introduction on why we're doing this. Obviously, it has to do with sustainability. And sustainability is that balance between the environment, the equity, and the economy. It needs to be socially sound. The people need to be happy with it. It needs to be environmentally sound. The planet needs to be happy about it, but it also needs to be economic viable. There has to be a profit, because otherwise a project will not happen. And where those three elements overlap, that is a sustainable development. And when you look about sustainability, the way the United Nations has done that, they've developed 17 sustainable development goals that you see symbolized here with the different logos that are being used for that. And the one sustainable development goal that we're going to talk about today, or covering most, is number 13, where it has to do with climate action. Because irrespective of whether the changes in climate are solely by global warming, or solely because of human interaction or not, that's a personal decision, a personal perspective. It is undeniable that we're putting more CO2 in the atmosphere, and that does have an impact on the climate. And as a construction industry, we play a major role in that. And when you look at the total global emissions, you see that something like 40% comes out of construction-related aspects. About 10%, a quarter of that is pretty much because of the building materials and the construction activity itself, and then an additional about 30% of the operations of the buildings. But what we're putting up is substantial. And more important than that, when you look at the building materials and construction, just three materials, concrete, steel, and aluminum, they're responsible for a tremendous amount of global emissions. Now, we're not using all the steel and all the aluminum for construction-related activities, but those three materials result in about a quarter of the total global emissions. Most of them, especially with concrete and steel, from the construction element, the buildings. And that means that if we can reduce the amount of steel and concrete that we stick in the ground, we can have a major impact on the global emissions. And that's why you then start looking at the embodied carbon reduction strategy. You've or many of you will have seen this pyramid before. You can build nothing. Obviously, if you don't build anything, there will not be any carbon emissions. At the same time, we have to build something because population is growing. We're doing new things. We have to build something. So that first option is really not all that realistic. We do have to minimize waste. What you see at the bottom. If we do that, it's only sound practice, but the savings are really not all that much. And therefore, what we need to do is we need to build clever. And it includes, as you see on the right-hand side of this to this pyramid, is that we have to start reusing materials. And reusing materials means that you obviously can recycle materials and reuse it again. But more importantly, when you can also look at another option of reuse of material, and that is really the reuse of a foundation. If you have an existing building that no longer fits the requirements, or an existing structure, a bridge or an aqueduct or whatever, that no longer fits the requirements, then the superstructure can be removed, but you still have that asset in the ground, and that asset is worth something. Now, the problem is that the stakeholders that you have to be aligned in that way. And the owner would like to hear the opinion of the different stakeholders. The geotechnical engineer, for him or her, reuse of foundation may not be all that interesting because they don't know what kind of material is in the ground, what kind of the condition of the foundation. They have not designed the foundation, and yet they have to assume then the risk that the existing foundation can meet the new requirements. So the geotechnical engineer is not all that happy about it. Similarly, the structural engineer, because if you have an existing foundation, it means that you have to design the new superstructure to match that existing foundation layout. Yes, you can supplement that existing foundation, but it still have an impact on your new superstructure. And therefore, it limits the options that the structural engineer has. Same thing with an architect. Suddenly, all his visions on how to design a building, how a building should look, are no longer all there, because you have to fit that layout of that existing foundation. And it means that they're not necessarily all that enthusiastic about it. And that basically means that the owner has to deal with a couple of things. First of all, you have to put in an additional investment to analyze the existing foundation. That's an investment up front. There may be a tremendous payoff at the end. But you also have to deal with a project team that is not all that wild about a decision to use that existing foundation. And for the regulatory body that has to approve this new structure, there's another problem. And Andy will, if not in his presentation, then I'm sure during the Q&A we'll talk a little bit about it, that there haven't been that many examples yet, so that the regulatory body cannot lean on existing guidelines or regulations or other case studies to say, yeah, let's do this. So once again, you have some reluctance to go ahead with it. And that's the same thing with the insurance company. The insurance company has to cover a superstructure on an existing foundation, something that hasn't been done all that often. Yeah, what is the consequence? Yeah, is the risk higher? And therefore, in the end, what you're going to get is when they vote on this proposal, you're going to get all negative votes. And the consequence is that by voting negative, yeah, we leave that asset in the ground. But there's another consideration, and you see that on the bottom of this slide, where people then say, well, listen, that existing foundation, you don't know the condition, but the new foundation, that's always perfect. But is it? Is it really true that when you put a new foundation in the ground, you are 100% sure that there are no flaws and defects in that foundation? And yet that is the perception, that a new foundation is good and an old foundation is questionable or should be questioned. And I think that's another issue that we will address, if not in the presentations, in the Q&As as well. So to avoid it, we leave that asset in the ground. Yeah, I've asked two people, as I said at the beginning, to give a presentation. One, Andy will give an overview of what's happening in the United States. Again, the impediments, those issues that we just talked about. and also the opportunities. And that will be then followed by Tony, who will be talking about a specific case study in Ontario. So with that, Andy, floor is all yours.
Okay, I'm probably sharing the wrong screen here. Okay. Thanks, Gerald. Thanks for inviting me to talk about foundation reuse, something that passion topic for both of us. So I'll give kind of a quick overview of run through a kind of a handful of topics, most of which derive from a survey we did about 10 years ago, but still has some relevant conclusions.
We're still on that first slide.
Yep.
There we go.
Okay, so DFI, one thing I'll plug right away, we have a new DFI committee on foundation reuse. It's actually not terribly new in a couple of respects. One, it's been about a year since it was officially made a committee. And it's actually been almost 4 years since we first formed this task force that's been operating like a committee basically for 4 years now. So our mission, I've got it written on the screen there, to reduce impediments to foundation reuse by 3 real prongs of activities that we work on. One is activities, which would be stuff like this, where we're trying to promote just outreach and increase awareness of foundation reuse. Promotion of technical advancements, so we try to support research endeavors and other kind of more technical things. Actually, we've collaborated with Tony and the Ministry of Transportation in Ontario. Both DFI and the ministry have funded some research that's going on up at the University of Ottawa. And then development of guidance. That's, as Gerald mentioned, that's one of the impediments to reuse, is a lack of guidance documents. So our committee is actively working on addressing that as well. I've got our website listed there, and I'm happy if anyone wants to join us. We're always looking for more committee members. We've got a fair amount of interest in the topic. I think evidence through the committee, we typically have in our monthly meetings about 20 people that log in, and not the same 20 people. It's always different because people are busy, and yeah, pretty good roster of engaged folks. I mentioned outreach. This is some of the case examples that are published on the DFI website that I linked to. We've got 6 of these published so far, and we're still working on more of them. These are kind of 2-page documents that give high-level project summaries and highlight some of the real tangible advantages of reusing foundations in terms of cost and schedule savings, which can be, especially for these big examples like we've got shown here, really significant cost and time savings that can be associated with reuse. The survey that I alluded to was through this is part of the Transportation Research Board's, the one prong of that organization in the States here is the NCHRP, which is the National Cooperative Highway Research Program. They do these syntheses every year where they pick, 20, or actually I think it's gone up from that, but they'll pick a pretty good number of topics that they'll study that span anything related to transportation, and so foundations get represented in that, if not every year, every few years. And so one topic that came up back in 2015 was foundation reuse. That was selected for study. So this is actually how I first got involved in reuse, was by doing that, performing that synthesis, where we surveyed all 50 transportation agencies, and I think we talked to the Canadian ministries as well. So I'm going to show some kind of highlight results. Of the 50 states, we had a really good response rate. I think all but 5 or so agencies responded, and all of the ones that responded, with the exception of Iowa, had experience with foundation reuse. I think Iowa probably does have experience now, if they didn't then. So very widespread for agencies to reuse foundations, but the experience varied widely, both in terms of the applications for reuse and how commonly they were doing it. So for most of the agencies, you can see on the bar chart here where, so N is the average number of incidences of foundation reuse over the last 10 years when the survey was done. So for most of the agencies, they're just doing it a few times a year, maybe. Or maybe even less. But there are a handful of agencies that are doing this all the time. They're doing it 10 or even more times per year. So those were the agencies that we tried to gather more information from. So we selected them as case example agencies that we talked to more, spent some more time interviewing and really kind of diving into their reuse practices. Some of the interesting findings from the case examples was one of the agencies, Massachusetts, has a big proportion of their infrastructure is in urban areas, so they deal with ground congestion a lot. It's also a relatively old state, so the ground has been developed several times. That's something we find also with I think a lot of the great experience in foundation reuse comes out of London, where of course they're on many cycles of reusing the same spaces. So ground congestion tends to be one of the real drivers for foundation reuse. Similarly, environmental constraints that can a lot of the NEPA stuff can put a lot of can really force the hand toward reuse. So in addition to cost and schedule benefits, honestly, a lot of the time that we're reusing foundations, it's because we really don't have any other choice. So that's fine. That's goes more to the feasibility thing. And there were another kind of common finding among the case examples was that these agencies have developed practices for foundation reuse, but don't necessarily have formalized policies or anything really comprehensive. So the challenges of foundation reuse, it's really it's the same challenges that we deal with on any foundation project. They're just kind of amplified. And I think that's what makes foundation reuse kind of fun from an engineering perspective. It mixes things up a bit. But we've also got to think about condition assessment. So load capacity, maybe not necessarily super different from a new foundation, but condition assessment is kind of the new thing. What kind of shape is the foundation in? And what kind of goes hand in hand with that is how much more service life can we get out of the foundation. And then the design codes, it can be kind of tricky if it was designed for loading and designed using methods that aren't used anymore. How do we translate that to more modern design codes? We've also got Gerald's nice kind of run through of the different players gets into this a bit, but the risk component, as Gerald mentioned, it's kind of perceived as more risky than new foundations. And I think that's, I agree with Gerald, that's not necessarily correct. Maybe it's more risky in some circumstances, but in a lot of circumstances, it's probably less risky. I think what's really true is that the risk is different. And so, where the risk of a new foundation, there's a lot of risk that it won't be installed properly, whereas maybe there's risks associated with condition stuff for an existing foundation, although I think in a lot of cases those risks are overstated. The other thing that's really different is the allocation of risk. And we've got kind of a system for, at least in the States, for how we allocate risk of foundations. When we start talking about reusing foundations, I think that can kind of upset the apple cart in terms of how risks get allocated among the different players that Gerald went through. And then I mentioned the lack of guidance, which our DFI committee is attempting to resolve. That tends to be a big impediment. It just doesn't give many, especially structural engineers and a lot of geotechs too. We like to have guidance documents that we can follow for obvious reasons, but I mean, not just because it gives us standardization, but it also makes people feel better. So, and like I've got there, it feeds into that perception of risk. So, like I mentioned, most of these agencies do not have any kind of formal policy. A handful did, but then once you kind of dive into the policies that exist, they're and this isn't to be critical, but they're not the kind of big guidance documents that people are really looking for. There's also room for improvement in how we're actually approaching reuse technically. By far the most common technique for assessing capacity of the existing foundation was just to use the capacity from original project documents, which tends to be very conservative, as I'll show from a few brief slides here on some research that we did for the Missouri DOT. This kind of came a few years after the survey project. But for this MoDOT research project, we did a really comprehensive field study of a couple bridges that had been in service for 60, 70 years. Did geophysical methods. We actually did static load tests of the existing piles using the bridge as a reaction. We restruck the piles and did dynamic analysis, high strain dynamic. And then we exhumed the piles and got to look at them. Here's the parallel seismic test. I won't get into the details, but really effective way to characterize the length of an existing foundation is this parallel seismic approach, which can be done with either a boring or a CPT rig, like we did here. We extracted the piles with the vibratory extractor there. Found that the piles were in great shape. Also confirmed the parallel seismic results. Did these static load tests. We had we've got the equipment parked on the top of the bridge to get us as much reaction force as we could get. And even with all that reaction force, we still couldn't fail at least one of the piles. The other one, I think we were getting there. So really what we failed on that, the pile that's shown with the black line there was we broke the capping beam that connected the piles, which we were using for our reaction frame. But what the real takeaway from this plot is just how much more load we put on those piles compared to the design load the design capacity that was listed on the plans. And if you'll recall, that's using those vertical lines was the most common approach for determining capacity, and that's just that's super conservative. So things like doing load tests when we can do them, I think is the best. But even just sharpening our pencil and doing a new analysis makes a lot of sense. We're going to do the same kind of research for the Indiana DOT. I won't get into the details, but basically going to try to repeat that and do some reliability studies. So real quick summary here. Frequency of reuse is difficult to track, but I think it's probably pretty more common than we think. We're trying to resolve that with our case examples for the DFI, where we can highlight some of these examples. But I think there's a lot of good ones, especially out there in the private sector, that we don't even know about. It is a topic that's getting more attention thanks to the efforts of Gerald, especially. Risk perception is a big impediment, and our DFI committee is working on developing guidance. So I'm gonna say the future is bright, and I think we're ready to hand it over to Tony.
Thanks, Andy. Thanks for your presentation. And again, to all of you listening, if you have any questions, please use the Q&A box to convey those questions to me. Before we go to Tony, one of the things that we always are looking for are organizations or owners that are actively pursuing foundation reuse. And the Ministry of Transportation Ontario it definitely falls into that category. And Tony will give you just one case study, but there's another one that he presented in the last conference that was held last year. And if you go to foundationreuse.com, you can see his presentation and the associated paper with that as well. But it shows that a government organization, that an owner that is sometimes dealing with other players in his team that are reluctant, can still overcome that and apply foundation reuse very effectively. And like I said, this is one of the case studies. So with that, Tony, floor is yours.
Thanks, Gerald, and Andy, thank you as well, and good morning, everybody. I'm just going to share my screen here, so just give me a minute to do that, and then we'll get started with the presentation here. A little bit of a delay here, I think.
Yeah, because right now we see.
Yeah, I got to get down to my presentation, right?
Yes, and we also see your presenter mode on the screen, and not necessarily the whole presentation. But anyhow, that's
okay. So that's go to display settings.
Yeah, this is perfect.
Okay, so let me get to the start here. Okay, again, thank you for providing me the opportunity to say a few things from the owner's perspective. And the first slide, I think, is self-explanatory, but I think it's important to understand that one of the things that we encourage here in Ontario is a partnership with other stakeholders, including our service providers, our consultants, and our contractors. So this presentation and the paper that we wrote was done collaboratively with a foundation engineering service provider. And it was the product of, I guess, an initiative. And this is just one case study. We've got several. But let me proceed to the next slide, if I can here. That's the outline of the presentation. So I want to give you a little bit of a background and then get into specifics about this one site location at Highway 9 in Greenock and what we call West Region. We've got 5 regions in Ontario. And the sub-bullets identify the process. And I'm a firm believer that if you stick to a process, the outcome will take care of itself. But I'm going to give you just a little bit of background in terms of our inventory, our infrastructure. And that's what the next slide is all about. So we have over 3,000 bridges, over 17,000 kilometers of highways, about 5,000 plus or minus structural culverts defined as culverts with spans greater than 3 meters. We've got a total asset value of about 100 billion. And we transport about $3 billion of goods and services on our highway system data. So a little bit of background in terms of the Ministry of Transportation of Ontario. When it comes to the reuse of existing foundations, before I share the content of this slide, I'm a big sports enthusiast. So that includes, hockey, baseball, and football. And starting with football, one of my role models was Vince Lombardi. And he had several quotes. But one of his quotes was, winning isn't everything. Wanting to win is everything. And what that simply means is, in order for any initiative to succeed, there has to be a will. And I'm very proud that I've been able to, encourage senior management at the Ministry of Transportation to make an investment in this initiative. And I think we're well on our way. And this case study is one example. The other slogan or quote that I want to share with you is, I'm a big hockey fan, and I recall back in 1999, the Colorado Avalanche won the Stanley Cup. And they had a saying in their dressing room. And that saying said, "It's all about commitment." And we are certainly committed at the MTO because of this several tangible benefits, whether it's traffic mobility, whether it's cost savings, whether it's favorable schedule impacts. There's a lot of benefits, of course, to the reuse of existing foundations, but there needs to be commitment. And we are committed. We recognize, as per the slide, our infrastructure. And if I were to give you a bar graph in terms of the age of our bridges, many of our bridges were built in the 60s. So with that, they're getting very close, if not at the end of their service life. So that, has an influence in terms of how we deal with things. So we have to make decisions. Do we replace them? Do we rehabilitate them, etc.? It may be a case where the superstructure, you have no choice but to replace. But foundations, I think there needs to be a focus, a lens, to see if we can salvage what's in the ground. And this is what we are doing via our guideline, which we have at the ministry. And of course, we've got this one case study and more. So I talked about the process. And what we are doing is, on every project moving forward where we are considering replacement or rehabilitation, one of the things that we specify in our terms of reference. So in commissioning a service provider, a prime service provider, and of course, all the functional specialties, including foundations, we actually include requirements in our terms of reference. So it's not like we're leaving this to chance. We're going to invest in investigation and engineering, make a preliminary assessment, undertake a risk analysis, as indicated on the slide, do an LCC, and of course, get into the details if, in fact, when we go through the preliminary assessment, it becomes a winner in terms of, yeah, you know what, the reuse is the preferred option. And then we get into the detailed assessment. But the point that I want to make is that, again, I always say that destiny is not a matter of chance, it's a matter of choice. So we explicitly specify requirements. Specifically, the one job that or one project that I'm going to share with you this morning is a project where, we have an existing bridge structure, as per the slide here, built in 1971, 18 meters long, single span, carrying Highway 9 over the Green Hawk Creek. Approach embankments in the order of 3 to 4 meters. Now, there are challenges at times I'm finding, and we're trying to remedy that with new requirements for new projects when we install new foundations, to look at any historical drawings, as-built drawings. And so we did that here. And you're going to see in the next couple of slides that the existing foundations at the two abutments are comprised of 22 steel H piles, HP 310 by 79, approximately 8 meters long, driven into a glacial till deposit. And I'm going to show you the stratigraphy shortly. We did a little bit of digging in terms of the design loads and whatnot, and we were able to ascertain that the piles were designed to support 630 kilonewtons per pile, or 70 tons per pile. Here is the original drawings that illustrate the layout of the steel H piles. So you could see on plan here for either abutment, and some notes here on the side in terms of some of the design loads and design capacities. And here is a longitudinal section that again illustrate the existing piles supporting the bridge. So we then proceeded to undertake a preliminary assessment, like I said, as part of the process. So part of that preliminary assessment, of course, we looked at comparing the reuse alternative with new foundations. And part of that was a risk analysis, as described by both Gerald and Andy, and making an assessment of risk, of course, cost, looking at traffic mobility. All these things were looked into, and it was concluded that the reuse was the preferred option. So then, with that determination, we then went into the detailed assessment of the existing piles. Now, in the best case scenario, it would be most advantageous to expose the piles if you could. But the conditions at this particular site, with high water levels and with cohesionous soils and with requirements for extensive shoring, it precluded us from actually exposing the piles. So what we did, as per the second bullet here, is we took an indirect approach. Similar to what Andy had described, we went into an in situ investigation to look at, what is it that we could do indirectly to make an assessment of the condition of the piles. So with that, what we did is we advanced a number of boreholes. And this particular slide illustrates the black solid circles indicate the new boreholes that we advanced at strategic locations to enable us to not only determine the subsurface conditions and validate the conditions that were determined way back in the day with the boreholes here that the original 4 boreholes, 1, 2, 3, 4, as I'm pointed to with the cursor. So we advanced 6, 3 at either abutment, but we did so with objectives in mind. 1, let's determine the subsurface and groundwater conditions. 2, let's look at getting samples so that we can make an assessment of the corrosivity of the soil and groundwater. And 3, let's use those boreholes, and we strategically locate them as close as we could to where we thought the existing piles were, so that we could verify the embedment length using geophysical methods. And I'll describe that in the next few slides. So here's some slides illustrating the methodology that we used. On the left, we advanced the hollow stem augers down to the depth that we felt we needed to explore. to determine the conditions within the embedment length and slightly below where we thought was the tip elevation of the pile. So on the left, you could see as well that we drilled through the deck to get us closest to the abutment wall here, so that then we could do the geophysical testing. And you're going to see some slides momentarily. We also had some portable equipment as well to help us get this close as possible to the existing abutments, which there were two, like I said, single span structure. So our findings were consistent with what we expected in terms, as you could see from this slide, the soil stratigraphy. We've got, as I indicated earlier, about 3 to 4 meters of fills, mainly sand and gravel. We had a deposit of native silty clay with some organics, as you can see here. And then we get into predominantly cohesionless soils, of which we had a sand and gravel deposit underlain by a glacial till deposit, a silty sand till. And we superimpose the piles, as you can see in red here, so that we could confirm not only the material within the embedment zone, but the material at the tip. So, by and large, we were either in the sand and gravel or in the glacial till, which had a very dense consistency. So we're able to confirm that. But we also, as I indicated, we did some geophysical testing. And what we did is we retained through our foundation engineer and service provider that did all this work for us. Again, like I said, we in our office developed the terms of reference, and then the execution of the work was done by a consultant, a Thurber Engineering in this particular case. And what Thurber Engineering did, as per the requirements in terms of reference, they commissioned a geophysical company who obviously had knowledge and experience in a suite of geophysical methods. So we tried 4 different types. We tried, and it was successful with the PST, which Andy had indicated he had done at one of his sites. We also did a borehole magnetometer. We had an electromagnetic method and a natural gamma method. So we looked at all 4. And here's some slides just illustrating the execution of the work going from left to right. We got the seismic, so that's the parallel seismic technique. You got the magnetometer in the middle, and you got the electromagnetic gamma survey shown on the right. Now, I'm not a geophysicist, but working with the geophysical experts, we were able to get interpretation of the results from all 4 methods. And you could see from this slide here, and specifically the bullet points, that the estimated vertical pile lengths based on the geophysical testing range from 6.1 to 6.3 at the west and 6.9 to 7 at the east. And, incorporating battle lengths and whatnot, we came up with the total lengths of the piles, and we compared that with the design pile length, and there was a pretty good match for 2 of the 4. So what we concluded was the parallel seismic and the borehole magnetometer were the superior of the methods, and the other 2 methods were not as accurate. So what we're doing on other projects is we're undertaking the same study to see if there's consistency in terms of what methods are better than the others. But for the time being, it's the PST and the borehole magnetometer that seem to be more effective. the corrosivity testing, we took a whole bunch of samples and we subjected the samples to chemical testing. And you could see on this particular slide, going from left to right, we tested for resistivity, we tested for chloride, and we tested for pH. And we plotted all the results on the particular graph so that we could, with the superimposition of the results, with the National Association of Corrosion Engineer, NACE, and the Journal of Applied Electrochemistry, be able to assess whether we're in a corrosive environment or not. And you could see from here that in the fills, approach embankment fills above the pile, the results illustrate that the soils are corrosive, but those are above the pile. As you get to the pile itself, as you can see here, we start going from, say, let's start here with the resistivity. We start going to, say, moderate corrosivity. So that's what this particular plot shows here. And then we looked at the chlorides. The trend is similar. Yeah, you've got issues with chlorides here. We use a lot of de-icing agents here in the wintertime that have cell concentrations, and it shows up in the results here. But we made a conclusion that below 1 meter of the top of the pile, the soils surrounding the piles were found to be moderately to mildly corrosive. So we made that conclusion. And with that conclusion, which is just repeated here, we went into our assessment. And our assessment, in looking at different, if I go back up to here, the second one is we looked at different codes and publications like Caltrans, NACE, Your Code, etc. And we looked at different corrosion rates. And we concluded that we were going to use 0.015 millimeters per year to estimate our suction loss. So with that, we were able to compute, the pile corrosion loss of the existing piles. And that enables us to then look at with the corrosion loss and the projected corrosion loss with the 75-year service life that the code here, the CHPDC, requires. With that calculation, we said, okay, here's what we expect over the service life of the foundations, what the structural resistance would be. So I'm talking to the left side first, and then we'll talk to the geotechnical afterwards. So we said, okay, with this corrosion loss, going through our structural capacity, our structural resistance, we came up with a computation of 790 kilonewtons per pile. We looked at what the demand was to compare with the capacity, and you could see from this that our demand capacity ratio was favorable. So we were then able to conclude from that from a structural point of view, that we were okay for the next 75 years. And we went through the same exercise, which is what we have on the right, geotechnically, by determining the lengths of the piles, ascertaining the subsurface conditions, knowing what the soils were at the tip and the shaft. We calculated the geotechnical resistance. We compared the geotechnical resistance with the demand. And again, the demand capacity ratio was less than unity. and we were able to conclude that we were okay from a geotechnical capacity as well. So now at conclusions. This study presents an indirect methodology for studying the impact of corrosion. An indirect assessment of the degree of corrosion was made to determine whether the existing foundations can be extended by a further 75 years. And we were able to conclude that that we were okay. And obviously the indirect approach was the product that we could not invoke a direct approach. The reuse of bridge foundation is a viable option that can present a significant cost savings for aging infrastructure. We've talked about this. Gerald's talked about this. Andy's talked about it. All of us are aware that there's a lot of benefits. The one specific benefit here is by reusing the existing foundations, we were able to save $500,000. The MTO plans to complete a similar assessment for other bridge sites. And I'm pleased to reveal to you that we've got one where we were able on a couple of sites related to a rapid bridge replacement actually get access to the piles. So we did some shoring, we did a little bit of excavation, and we did some ultrasonic thickness testing. We did took some samples and did a very comprehensive. So we are doing a direct approach wherever we can. And what we're doing as well, as Andy indicated, we've got at least 3 sites where we've gone to the site and where we're replacing a bridge, say an existing 4-span with a 2-span, and there being some obsolete foundations. We went to those obsolete foundations and did the suite of testing that Andy indicated in terms of in situ axial compressive, lateral, taking samples of the soil, extracting, doing some corrosion assessment. So we're developing a database so that we've got different soil conditions, assessing the aggressivity, looking at the type of piles, so that it gives us more confidence moving forward, so that we could continue to consider on all our jobs the reuse of existing foundations. And I'll just conclude with one last saying. I am renowned for slogans and sayings. Actually, 2 things. I always say that, 1, the road to success is always under construction. So we're building. And I know that there was a slide that Andy had. And I'm going to ask the question, and I think the slide will come to our minds that I'm referring to. And the question is, what's the largest room in the world? Well, everyone scratches their heads and thinks about what possibly could be the largest room in the world. And I always say that the largest room in the world, consistent with one of Andy's slides, is the room for improvement. So the Ministry of Transportation, we have our strategic directions, our priorities. And one of those priorities is to upgrade the technical standard and to improve the state of practice. And I think we're well on our way, and we look forward to gaining more knowledge and more experience in interacting with folks internationally, so that we could be more knowledgeable and make better informed decisions. Thank you. That concludes my presentation.
Thanks, Tony. Thanks for your insights and your overview of this on this topic. And very interesting to hear what MTO is doing in that regard. We have a few minutes for questions because I want to keep this this webinar to 1 hour. Andy, one question that came in on your presentation. You said you did a load test on that one bridge that you and then actually increased. Were you able to find out what the original load was on the pile that was put there by the existing bridge?
Good question. And I like where the question's going because I think we should take advantage of known loading information. So I'm sure that the strict MoDOT answer would be, well, it's something less than that dashed line, right? But this was in a very rural part of the state, very productive farm area, and we talked to some of the locals in the area, and they said that routinely there were huge trucks carrying all kinds of agricultural goods that would cross this bridge. So I would imagine it's something actually on the high side of those dashed lines.
Just for the benefit of the people that maybe not already looking forward to what you did on where this question was going, can you explain a little bit why this is something that we should be doing more often, what this existing loading is?
Yeah, like if we get really in the weeds technically on it, if you think about your reliability analyses where we have this bell distribution or bell curve that we assign to the foundation resistance. When we have an existing foundation that's in the ground and we know it's been loaded to something, you can essentially lop off the left tail, which is where all the failures come in. So if we can establish that the known loading is something greater than what was on the plans, this is part of what we're trying to do with that upcoming Indiana DOT research is how can we take advantage of that loading information in a probabilistic way and make our designs a little less conservative.
Yeah. Okay. Unfortunately, I don't have time for the other questions. If you ask a question in the QA box, I will make sure that Andy and Tony will respond to those questions. What I want to do in the next couple 2 minutes that are left here is first of all point you to the foundationreuse.com website where you have all kinds of information about the previous conferences that were held. All the presentations, all the papers are freely available there. Webinars like this one, the recordings of that are available, but also in the resource center, we have collected all kinds of documents, general documents, presentations, case studies, and guidance documents that we're aware of. And Tony, if we don't have the MTO's guidance documents that you have there, that you refer to, we would like to post that as well. Obviously, we will continue with these webinars on the first Tuesday of each month, each odd month. We will have a webinar. So the next one will be in early March, and we will keep you posted on that. Then, of course, we have the next conference coming up in the end of March in Amsterdam for the third time that we're there, and most likely it's going to be the last time in Amsterdam. We hope to go to a different location. And then also in September, first talk about the DFI EFFC conference in Bruges in May of this year. There we talk a lot about the sustainability aspects as well. But I was going to talk about very briefly about a workshop that we're doing on foundation reuse in Canada. The Canadian Geotechnical Society has an annual conference in September, and we will have now the day before that conference a one-day workshop, and we hope to make that an annual event as well, that whenever CGS hold their conference, in this case Geo Manitoba, in Winnipeg, we will have a workshop there on foundation reuse. And with that, I'm right at the top of the hour. I want to thank Andy and Tony again for giving their presentation. I want to thank you for being there. I want to close with one remark that somebody made during the presentation. He said, basically, if you leave an unused foundation in the ground after the demolition of a structure, It is a form of soil pollution, and it should be regulated accordingly. Maybe that's another approach that we can use to really promote the reuse of foundations. And with that, thanks again. Thank you for being here, and look forward to seeing you in 2 months at the next webinar, and otherwise maybe at the conference in the end of March in Amsterdam. Thank you very much.
Thanks, Gerald.
Thank you.